Hello and welcome to our weekly innovation coffee brought to you by ARM. We have some exciting stuff to discuss this week as we're joined by Jonny Austin, who is the CTO at Microbit. But before we dive into the segment, let's first revisit the stream from last week. So during our stream last week, we were joined by Angel Rivera, who's the senior developer advocate with Circle CI, where he spoke to us about Circle CI's new ARM offering and what it means for developers. He also then built out a demo which showcased the use of this new ARM offering among various other components such as Terraform and AWS. It was a lot of fun. And if you have some extra time in your day or your week, don't forget to check it out. We're going to share last week's episode of Circle CI in the chat. So, after this episode, make sure you go check that out. And gosh, my computer is, I'm still trying to get this set up. If you haven't noticed, compared to all of our previous innovation coffees, this is a new setup, right? Maybe no one's even noticed it yet, but this is a whole new setup. I'm getting my new office set up here. I don't have any lighting in it yet, but my internet is also kind of glitching out a little bit. But yeah, okay, cool. Newsflash, this just in. If you haven't already signed up to the ARM Dev Summit call for proposals, the deadline has been extended. All right, so submit your proposals to be a speaker. This is our annual event. We do this every year. It used to be ARM TechCon. Now it is called the ARM Dev Summit. So make sure you go check it out. If you have any more questions or if you want to learn more about this event, make sure you go to this website right here, devsummit.arm.com. We're always looking for new speakers here. So make sure you go check it out and see how you can participate with us during this event. Now, I just want to remind everyone that if you like this video, make sure you smash that like button. It definitely helps us out. Subscribe to our channel, the ARM Software Developer YouTube channel. This is the Twitter account right here. Go follow us on Twitter. And if you have any questions throughout this entire hour here where we're joined with our featured guest, make sure you post those in the chat. We try to get to as many questions or all the questions that you post in there. And we love hearing from you, your comments and your questions. We'll feature them here on the broadcast. So get those questions in. All right. So now let's bring on our guest. I'm pleased to introduce Jonny Austin, CTO of Microbit. Jonny, welcome to Innovation Coffee.
Thanks for having me. Thanks very much.
Yeah, of course. And you have your coffee with you?
It's tea.
Or tea?
Okay. It's tea. So we're going to clink in the afternoon in the UK for coffee, but yeah.
We're going to clink it together right here. Clink. Yeah, cool. So welcome, Jonny, to Innovation Coffee. And usually what we do at the beginning of these sessions is we want to get to know you. Who are you? What are you doing here on Innovation Coffee? What do you do for Microbit? So maybe you can just take a couple minutes to tell us a little bit about yourself, your origin story.
Sure. Yeah. So I'm the Chief Technology Officer at the Microbit Educational Foundation. I'm seconded from ARM. So that means I joined ARM as a graduate a long time ago now, and worked initially on kind of bringing up Linux on ARM v8 when that was new. Worked through that team, worked a little bit on the Linux kernel, and then went to work in a team called Embed, who designed kind of developer-focused embedded devices. And ARM has a kind of sabbatical program, so you get to take 4 weeks holiday every 4 years. And I came back from my sabbatical and was looking for some new challenges. And actually, right at that time, the BBC were looking for partners to work on this project that they then was called the Microbug project, not the Microbit. And I got involved in supporting the BBC on ARM's behalf in developing a kind of coding device for kids that became the Microbit. And since then, I really enjoyed it. I got more and more involved in what the Microbit was and helping to support the Microbit project, until when ARM and some other partners helped create the Microbit Educational Foundation, I ended up moving into the foundation on secondment. So for the last 4 and a bit years, I've been leading the tech team in the Microbit Educational Foundation, helping to inspire kids around the world to get creative with coding.
That's awesome. That's very awesome. Thank you for sharing your story there. You did kind of touch a little bit on the history of Microbit, but I'd also love to hear that. I know, so I was looking this up. Microbit was founded in 2016. Is that correct?
Yeah. So the Microbit Educational Foundation was founded in 2016. It was based off a huge kind of collaborative project in the UK. So the BBC brought together about 29 partners in order to create the thing that was the BBC microbit. And it came actually about as in the context of a curriculum change in the UK. So the UK in 2014 changed its computer science curriculum and said, we want to teach not just how you use Excel, not just how you use computers. We want to go back really to the kind of the 80s and 90s where kids were programming computers in schools, and we want to teach computer science. And the BBC looked around at how they would help this, because the BBC in the UK has a remit to do education as well. A lot of you around the world will know the BBC as a broadcaster that does kind of TV and radio programs, but actually in the UK, they do a lot of educational material and educational resources. So they wanted to work out how they could teach this new curriculum and support teachers and students in it. And they concluded they needed to create something new that would be really focused on education, but would bring kind of developer class technology into the schools and allow kids to do it. And they had this bold goal. They said, we want to make 1 million of them and give one free to every year 7 in the country. And they did it. So, you know, the way to cut a long story short is to say they succeeded in putting together a partnership that included Microsoft, Lancaster University, Premier Farnell, Samsung, a whole load of other organizations, and ARM to put together this project. And once it had been delivered into UK schools, it fell, you know, it wasn't for the BBC to keep running that. They're not a hardware company. They kind of got it started, and they wanted to create a not-for-profit foundation that would keep that going. And that's how the Microbit Education Foundation came about.
That's amazing. I think it's a dream for a lot of companies, maybe like Microbit, to get such backing from not only a government entity, but a government entity that's willing to put so many of these strong partners behind it. And you said a free microbit, or let's call it a subsidized microbit, that goes to every year 7. So every child
kind of 11, 12-year-old in the UK in 2016 was given a device for them to use for programming. But you know, just to be really clear, that the Microbit Foundation didn't exist. It wasn't like the Microbit Foundation had this lovely idea and they wanted to get backing for it. It was actually, you know, the Microbit owes its existence to that partnership. You know, I was involved in the project, but can in no way claim to have created the Microbit. I was one of a huge team of people that put together this thing that is the Microbit now and has its own life. And I think, you know, one of the things that's so fantastic about it is that it pulls in technology, ideas, creativity from that broad spectrum, you know, from design companies, from educators, from a group of teachers, from Microsoft, from ARM, from Lancaster University. So I think it's inspiring to have that kind of backing, but also to have the range of voices and the range of people, you know, and sometimes they're all pulling in crazy different directions, and you're like, this is just not going to happen. Like, we're not going to get past this. You know, there's always difficult times in a project like that. But actually, I think what Microbit is all the better for that collaboration and pulling and understanding what was really necessary and what people really needed in the classroom.
100%. So thank you for sharing all of that. I think it's time for our icebreaker round here. We're going to do what's on your desk innovation coffee cribs.
So my desk is a little bit, it's an odd place. I'm actually not, I've been spending, we had a baby about 12 weeks ago. So I've been not working at this desk.
Congratulations.
Thank you very much. But things that are on and around this desk, I found an iPod Classic, which I absolutely love. That's still use. I've got, this might come in a bit later. I've got a parrot, which my team in Microbit, I think, are absolutely sick of. I think they really hate the parrot. But I love the parrot. So we can talk a bit more about the parrot. Yeah, and obviously Microbits.
Lots of Microbits.
Lots of Microbits. Although you'd be surprised, it's far too common for me to be like, where's my Microbit? Yeah, I want to check where have I put the Microbit? So yeah, there are Microbits, but actually not as many as you might think.
It's funny, that old iPod that you just showed, my wife has 2 of those, and she's looking for, I think it's a 30 pin or a 32 pin connector. She needs that because she wants to charge it and see what songs and photos and all that stuff she has on it from back in the day. Yeah, ship it my way, because
you want the one that's being pulled apart. I think there are far too many iPod Classics in my house.
Oh, nice.
That way.
Cool.
Various different states of restoration.
Well, I think that with this icebreaker round, the introductions to yourself and, of course, Microbit, it's time to move into the main segment. And unlike some of our other episodes, we're going to kick this one off with a demo. So I have here at the top of my list a demo on an example project with Microbit, and this one's going to be microphone based. So maybe, Jonny, you want to explain first? Let's talk about what you're going to show us at a high level, then we can dive into the demo.
Sure. Yeah. So Microbit V2 is the latest version of the Microbit. We released it last year, and it adds, if you've seen a Microbit before, this is a Microbit V1. If you've seen a Microbit before, you'll know that it doesn't have the ability to make and respond to sound. So Microbit V2 has the ability to make and respond to sound. So I'm going to just show you some of the things you can do with sound. And I'm going to kind of start with a really simple program, but we're going to kind of use what we do in the simple program to understand how we could make something a little bit more advanced. So this is a lip syncing Microbit. So as I talk, it's listening to me and making a face that matches, well, it doesn't really match, but it's trying to, based on the volume of what I'm saying, draw a face. So if I go bop, 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 sorry, my team might also say that quite a lot of the Microbit V2 process was an excuse for me to make silly noises at a camera while we were remote working, and I definitely did do that, but that isn't why we did Microbit V2. But so yeah, we're gonna look at the way the Microbit you can code the Microbit to respond to sound.
Can we cut that little piece of you going bop 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 and put that on Twitter?
I mean, sure. I think at this point there were enough clips of me making silly noises to devices that it's out there. So long as the Microbit features, so you can see that I'm not just doing it to please myself, which obviously I would never do, then yeah, that's fine. So I think what I'll do to show you how we build this demo is I'll start by, I'm going to use the Microsoft MakeCode editor. So this is one of the primary editors for the Microbit alongside the Microbit Python editor. So I'm going to share my screen so we can see the MakeCode editor. You might get a kind of brief picture-in-picture exciting view as I do this. Because I'm going to give you my whole screen for a moment. So there we go. So is that working?
That is working. There it is. So this is the Microbit website, makecode.microbit.
This is the MakeCode website. So if we could start from microbit.org. This is where kind of everything kicks off, and you've got a whole bunch of information about the Microbit here. Get started, projects, lessons, but we're going to go here. Let's code. And then we've got kind of details about each of the editors, MakeCode, Python editor here, but we're going to jump straight into MakeCode. So let's do it properly. I'll close that tab and click this one. And we're going to make a kind of simple hello project. So hello, coffee drinkers. Although I should really have said tea drinkers. It's a lie because I'm a tea drinker.
I'm a coffee drinker. We're good.
So this is what the first thing you see when you open Microsoft MakeCode looks like. And on the left-hand side here, we've got a simulated Microbit. So this is running in the browser, and it's showing you what your Microbit will do when you deploy the code to the Microbit. In the middle here, we've got what's called the toolbox. These are all the things kind of for, as this is a more technical audience, these are all the API calls that you can make, but they're rendered in block form. So they're kind of easy to explore what the Microbit can do. And there's some advanced ones as well. And then on the far right-hand side, you've got your code. And at the moment, my code does nothing. And we've got, you can see here, we've got a little USB symbol. And that means that my Microbit is actually connected via USB. If we want to, I think it's probably best to give you the full experience. So I'll disconnect my Microbit from USB, and we can have a look at, while we're talking about innovation, this is one of the innovations in the web recently that has really helped enhance the Microbit experience. So let's look first at the kind of what the Microbit experience would be like if you weren't using WebUSB, and then we'll look at if it were. So we're going to start with some sounds. So not the microphone immediately, but just making some sound with the Microbit. And this is, one of the things that we were really keen on when we did Microbit V2 was making sure that even though we had real type cost targets for the Microbit, the more people that can afford a Microbit, the more impact we can have as an educational not-for-profit. We wanted to make sure that the sound we got had a kind of emotional connection, really fitted with the design ethos of the microbit, was friendly. So we spent a lot of time on these friendly sounds. So we're just going to start with using some of these sounds. So when we start the microbit, we're going to play a sound. Let's just play hello. Very simple. And we might accompany that with a little with a face. So we're going to grab a block, show icon, and we'll show a kind of we'll start with a smiley face. So play sound hello, and you already heard the simulator runs the code automatically. I think you can hear that that sound hello, and that should be like hello, microbit saying hello. You wouldn't believe how many times I had to also make strange sounds at the camera before we got these.
Is this where the parrot comes in? Because that kind of sounds like the parrot.
It sounds like, yeah. So yes and no. Let's hold that thought.
Okay. Okay.
So, but we can make it. We can do more than this. So we've got the way you can do stuff on the microbit is you can have these event blocks. So I'm going to do something when button A is pressed. This is just a really simple demo to kind of get us thinking about what the microbit can do and how we might use it. So on button A pressed, let's duplicate we'll show a heart. Hooray. And we'll play a different sound. Which sound should we play for heart? Let's play twinkle. And then we will, in fact, we'll delete that. We'll duplicate the whole block. A bit easier. Duplicate this. And now we will show a sad face, and we will play the sound sad, and we'll do that when button B is pressed. And one of our design goals for this was that when you heard the sound the microbit made when it was sad, you might actually feel sad. So if I just play this now. Oh, so that's a sad microbit. And this is a twinkly microbit. So we actually looked at a bunch of things for these sounds. Parrot was one, but also children's TV. We looked at the kind of characters that had very limited voices, but that still people had an emotional connection with. So a very old thing in the UK called the clangers, and also things like Wall-E, R2-D2. These are all characters that have real they're really communicative, even though they use a very simple palette of sounds. So far, I've just shown you something on my screen, which is, it's quite nice, but it's not what we really want. So if I just switch camera, sorry, I'm giving you the full view of the works here. This is my microbit on my desk. What I'm going to do is, if you can see my screen, hopefully, and my camera at the same time, when I switch back to make code, if I want to put this program on my microbit, I can click the download button. And it builds this is actually, for those of you that are kind of familiar with ARM tools and compilers, this is actually compiled this program into ARM assembler in the browser and concatenated the program with a pre-built C++ kind of runtime, or it's a kind of pre-built blob that contains a lot of these underlying functions. So the actual compilation of my program just happened in the front end, generating ARM assembler from JavaScript, which is kind of neat. So if I show this program here, this is microbit hello coffee drinkers, and I'm going to drop that onto my microbit here. And if you see the microbit now, the LED on the back should be blink, 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 blinking. So this is flashing. It's not flashing because it's flashing, but it's convenient that those words sort of overlap. And now you've got the happy face, got the twinkle sound. And then I hope you're all ready to start feeling a bit sad. Oh no, the sad sound. And if I show you, so that process, that was fine. And the thing that's brilliant about that process is that it really works everywhere. So, if you've got a computer that can plug a USB mass storage device into, and you've got a web browser, then you can program a microbit. And one of the absolutely key goals of the microbit was that, we would make it easy to program, and any school, if we think back to that 1 million devices given out in the UK, there was no way to check what kind of infrastructure the schools had. It just needed to work everywhere. And so that drag and drop is brilliant. However, if I use this little ... here and choose pair device, I can use a technology called Web USB to connect my browser directly to my microbit. And now if I change something about this program, so let's change the icon we show straight away. Let's show a very tired face at the beginning, and we'll yawn. If I do this now, when I hit download, we are going to send the code straight from the browser to the microbit device. And my microbit now should restart with the code running. And there's our yawn. And you can hear yawn coming out of the microbit, and the program still runs. So great. So far, so fun. But I haven't shown you anything about the microbit. So that's how we make sound. What about responding to sound? So I'm gonna use this as a chance to sort of shoehorn in a demo of one of the other. In fact, I'm gonna mute my simulator here so you don't keep hearing these noises, because lovely as they are and designed by a sound designer as they are, still quite annoying if you hear them too often. So I'm gonna also show you another feature of the microbit V2, the logo pressed feature. And we mapped this. One of the things we're really big on is helping students understand the devices they have in the real world through the use of the microbit. So the microbit logo on V2 can respond to touch. And the actions you get are very similar to the ones that you would have for a touch screen when you are handling events, say in an app or in a browser. So you've got pressed, which is push and release, or you've got just touched, which is when you just push down on it. So what I'm going to do now is I'm going to do a loop. And when we touch the logo, while true, so we don't want to be stuck in this loop forever. We only want to do this loop while the logo is pressed. So this shows you two different ways you can interact with the hardware on the microbit. You can either use these Boolean values about whether it's pressed or not, or you can use the events. And this is similar for the sound. For the microphone, if you look down here, we've got, for microbit V2, we've got on loud sound, but you can also just read the sound level directly. And that's what we're going to do here. We're going to use this LED plot bar graph feature. So we're going to plot a bar graph of the sound level up to, and I know that this goes up to 255. If I didn't know that the maximum sound level was 255, I could right click on this and choose help, and it would tell me about the sound level block. But it's often very slow when you're sharing your screen. I don't know why. But that gives you details, help about each of the blocks. We'll tuck that away for now.
Real quick, I love what Arjit is saying here. He says microbit, and we touched on this at the beginning, but he says microbit was the very first STEM thing that was bought by his school's Robo Club.
Fantastic.
Hashtag memories. Yeah. So.
That's exactly that's exactly what it's supposed to be, is really appropriate for education. And hopefully you can see from this experience that, it really does meet that. So the last thing I've got to do to this program is I've got to put a little pause in. And one of the reasons this is necessary is that the microbit is super, it's a kind of, if you think you've got all these events, but they're kind of cooperatively multitasking, it's just a microcontroller. So if we don't have the pause, then we never yield control for anything else to happen. So we have a little pause in. So what I'm going to do is, when the logo is touched, I'm going to enter this loop. And while the logo is still pressed, I'm going to plot a bar graph of the sound level up to 255, which is the maximum value of the sound level. Oh, it was there, and then it's refreshed itself as I've opened back out. Oh, well. And up to 255, and then I'm just going to pause for a little bit and go back around the loop. So if I download this program to my microbit, I think you're probably still seeing my screen and my microbit. If I click download now, what I can do, wait for it to finish updating. That's yawned. If I now put my finger on this logo and talk, you can see that while I'm holding the button, the microbit screen is responding to my voice. And so although this isn't exactly the demo that I started with, you can kind of see how using something very much like this, a while loop and the sound level, you could draw some different pictures on the screen based on the different values of the voice. And in fact, if we wanted to just make a kind of super simple of what we did, super simple version of what we did, I can. So I've let go and the screen stopped updating. If I push a button, the other events fire. If I just take these LED, I can plot individual pixels. So if I then plot, we want to plot, X, and we want to do another plot. Who knows if I'm getting my X and Y the right way? Ooh, hello, where is that block gone? I think that's what I was expecting. Plot X, Y, 3. And now we can try this. So we can have a look if I touch the logo. I've almost drawn two little eyes. So now if I download this to my microbit, we'll see that I've kind of built a very simple version of our lip syncer, but it only happens when you're touching that logo. So we've got, and we've got a lot going on in this program, but it's not many blocks to be able to do that. So here we go. And now I've kind of built something a bit like that demo I showed you at the beginning. Woo! Pow! I can make silly noises again. How's
Very
that?
cool. Very cool. Very cool. Here,
Fine.
let's bring this view back in here. So that's awesome. In fact, some people were bringing up here in the chat. We were able to post some of them. But yeah, another person here, Harold, who was saying microbit was where he got started a year and a half ago. Very easy, and from what I've seen, you kind of mastered the low code, no code barrier to entry with the opportunity to expand. And this brings on kind of, I guess, another question from me here. What are your thoughts on this whole no code or low code, no code movement? Because, we've had other people on the show. They've talked about it a bit, but this seems kind of like the perfect opportunity to hear from you, an expert in this field, low code, no code with microbit. What are your thoughts moving forward here? How is this affecting developers?
Yeah, so I think I spend all of my working day thinking about how this affects students and teachers. So my opinion comes with a caveat that I spend my time thinking about that audience. But I can tell you some of the things I've observed about the way I work differently with this. So if I'm going to build a complex program in MakeCode, I will almost always, despite the fact I'm an embedded programmer, my background is in opening a text file and typing out the code. I find myself almost always fleshing out the overall structure of the program, all the events, all the event handlers, what's going to happen when in the graphical environment, and then switching to the text-based environment to fill out kind of all those function bodies, that kind of stuff. So I think there's something at least that works for me, and I think will be quite valuable for other people about the kind of the structure of a program being much more useful to think about visually. And there's lots of precedent in this. There's people doing UML and all that kind of stuff. But I think the idea that it's not, the idea that representation of your code is your code is really powerful. So, if I just switch back to MakeCode for a moment, I think you've still got my screen.
Yeah.
If I switch over, you can see this program that I've got here in Microsoft MakeCode. I can switch to JavaScript. And that's going to convert my code into JavaScript. And I can have a look at my code here. You can see this is us registering the event handlers for button A, button B. This is our on logo event. This is my LEDs. I can change this code here. I can change the delays. I've got auto completion, so I can change my icon name dot. So it took a little while, but I can kind of choose. Let's choose fabulous, great, or a duck. I like a duck. And if I switch back to blocks now, I've got the best of both worlds, because now you can see my program has changed based on the changes I just made in text. I find that really useful because I think there are massive limitations to how easily, if you want to build even a moderately complex mathematical operation, it's so much easier to type it than it is to build it with these units. But if you want to do these kind of simple programs, then I think the kind of low code environment is super powerful. And sorry, I'm giving you infinite mirrors again. That's why I'm not going to go back to my screen. I'll give you a warning when I'm going to come back to this view. So that's one thing. I think the other place where I personally see this being hugely powerful is plugged into kind of configuration UIs. And I'd love to see something like this for CI pipelines. I'd really love to be able to use something like MakeCode or a Blockly-based graphical editor for kind of plugging together what actions should happen when you've got an event for on code committed, on pull request raised, on things like that. I think these kind of event-based things in CI could be a really low-hanging fruit for some of this low-code stuff as well. But that's like personal speculation. But I totally think we need to start moving away from the idea that block-based languages are not code, because I think it's really clear that they are the beginning of a full code program, and you can express very complicated things in them. It's not about complexity. I think it's about having the right tool for the job, right? And yeah.
Absolutely. I remember back when I was first going through my first C course, right? And this was almost 10 years ago now. But one of the first things that one of my more senior coding friends told me about, he was like, let's first just, what are you trying to build here? Okay, you're trying to calculate a Fibonacci, sort of Fibonacci sequence. Okay, well, let's just turn it into blocks real quick. And so you pull out your piece of paper, you just draw out the blocks of your functions. What do you want this to look like? What are you calling on? Okay, well, now let's create our variables. Now let's create all these different pieces. And so you kind of start filling in your blocks, right? And it seems that this is kind of like what you're doing here. One of the other things that I think is very nifty is that when you're switching between languages, sometimes it's just that little syntax that you're trying to kind of grasp onto. And so, you just switched from blocks to JavaScript, and I'm sure there's other options there. Maybe switching from
Python as well. Yeah,
there you go. And so if you're just trying to remember what that syntax is for that particular loop or whatever you're trying to build, just switch on over and you can see what the syntax is. Might be also a really great learning resource as well.
Totally. Yeah, and I think we're experimenting internally with the microbit Python editor, which I haven't shown you. I'd love to show you quickly before the end at some point. But we've got a Python editor as well for typing MicroPython for the microbit and deploying it smoothly in the same way. And I think we've been thinking about that, as a text-based experience, and how, I think there's a lot to learn, not just from that kind of toolbox view, but about how we support learners in exploring the APIs of their program. Like, I'm not totally convinced that text-based documentation is kind of, we've been working up towards this with autocomplete, with documentation on hover. I think there will be some really interesting opportunities for bringing in new audiences into programming. I think sometimes if you're a really familiar programmer and you really know your APIs, this stuff kind of can get in the way. So I think what's really interesting about these systems is that they are incredibly valuable for bringing a new audience into that computing area. And I think that's incredibly important, not just for kind of the diversity in the industry, but I think for the diversity of thought and the ideas, right? If all the people building tech products come from a particular background, particular way of thinking, then we get this kind of homogeneity in the tech world. And I think one of the reasons that microbit feels so important to me is that I think changing the diversity, the different new perspectives, new ways of thinking in the computing industry, and kind of building this body of diverse, interesting people that come from different backgrounds that feel a mastery of tech and feel empowered to build stuff with tech, I think is going to have a really positive impact on society.
Awesome. So Jonny, we have a question and a request in the chat here. So I'm going to bring the question up first. This is from Sandeep. Yeah. He says, do the audio processing blocks use CMSys DSP under the hood?
So I almost want to open a pull request to answer that question, because right now they don't. So the audio processing is super simple at the moment. Why don't I just open a pull request? So the reason I should do
should we share your screen again?
I'm not convinced that I know where it is. So it should live in, I'm not in my main account, so I don't have a history. So let's try type github.com/Lancaster-University.
We're gonna bring your screen up here.
Okay, university/podal-microbit-v2. So here we've got some pull requests. This is some stuff that some students at Oxford University did recently, and they were working in collaboration with us to kind of look at some interesting ways you could use the microbit, and they kind of built this emoji pipeline, or this kind of audio pipeline out of some of the tools, including, if we go to this fork from Josh Hill, who's a student at Lancaster University, that does use CMSys DSP in order to do kind of audio processing to get frequencies to do, for example, here, a fast FFT. So good question, almost like a plant, but not a plant, because I wasn't expecting to show you a pull request. But this is just a kind of very much a snapshot of the kind of in pipeline development that's going on in microbit Codal.
On the way, Sandeep.
Yeah. Yeah.
Cool. So
I'm gonna switch back the camera. There we go.
There we go. Okay, take that away. So here's a request from Arjit here, and he's wondering if you could please talk about microbit plus ML. Do you have anything to say about microbit plus ML?
I do, yeah. So so the microbit V2 uses a Nordic NRF 52833, which is a Cortex M4F. It's got 512K of flash and 128K of RAM. I don't want to. It's always on the call is when you suddenly get those numbers wrong. But so that's enough to be running kind of TensorFlow or Edge Impulse or other technologies like that. And there's a really nice demo. I've got a nice folder on my machine here called Here's One I Made Earlier. And in my Here's One I Made Earlier folder, we've got a microbit voice recognition example. So if I just drag and drop that onto my microbit, then hopefully this will give you a nice example. So what we did around the launch of microbit V2 is we teamed up with Edge Impulse, and they worked with us to build a demo where the microbit will recognize me saying the word microbit. So here's my camera. I think it will anyway. So if I say some words, nothing happens. But if I say microbit, no, like microbit. There we go. So we have the training data for that is actually a pretty small amount of training data. So what we've actually got for that is one of the most bizarre microbit foundation team calls. We have an all team call on a Monday, and we had an all team call where every member of the team said microbit 3 times. And then the next member of the team said microbit 3 times. We just recorded a bunch of samples of people saying microbit. And I've never felt quite so much like I worked in a cult as that team call where we're all just microbit. Anyway, that's there's a nice edge. If you have a look, there's an Edge Impulse demo for microbit that was part of the launch blog that kind of shows you how to get started with Edge Impulse on the microbit. Look at that. There we go.
Very cool. Yes, I think that should answer your request. Should satisfy your request there, Arijit. There's some cool stuff going on. And it looks like there's also some opportunities for you to create some stuff. And so, yeah, here we go. Hashtag TinyML, hashtag Edge Impulse everywhere. Very cool. All right. So I added this little segment here, Jonny. I want to kind of like move into something a little fun.
Sure.
We're going to test
Hold
your
on.
knowledge.
What are you saying about my demos?
Your demos are good.
I'm going to have to get the parrot out if you. Let's do your fun.
Okay, this is going to be some fun. I have found a quiz online, a microbit quiz, and we're going to test your knowledge here live with everyone here. So let me pull this up. Actually, I got to move this over here so that I can share my screen. Oh, shoot. I'll move this over here, and then I'll move this over here, and now I should be able to share it. Let's see. All right. Okay. So, Jonny, this is 10 questions. I'm going to be able to pull up the answers afterward, and we're going to test your knowledge on microbit.
Okay, let's go to the top. I want to make a note. So just the very first picture, very higher. Scroll up.
Higher. Okay.
That one is a prototype microbit. The picture there with the fringe going all the way across, prototype microbit. No idea where they got that picture. Anyway,
interesting.
Carry on.
All right. So first question, how many LEDs does the microbit have? No counting. That just makes it bigger.
None of these answers are correct. The microbit has 26 LEDs if it's a microbit V1 or 27 LEDs if it's microbit V2. But I think the answer they want is 25. Sorry to be that guy.
What?
But it's literally my job to be that guy, because if I didn't know how many microbits LEDs there were on the microbit, we wouldn't be making them very well.
Why can't I answer it? It's not letting me click on the answer. Maybe if I refresh, let's see. I was supposed to be able to click on those so that we can. All right, well, let's just show the answer, and it's 25. All right, so maybe this is outdated. Maybe the prototype had 25.
No, I've got one of them somewhere in a drawer. No, there's always one on the back. But so it's a reasonable question. If you said how many LEDs can the user control on the microbit, 25 is correct, but they're forgetting the ones on the back.
Okay, well, there you go. Then I guess that's a clever answer.
Yeah, I mean, sorry, I'm a terrible person. Carry on.
Well, we'll say you got that one right. Which device on the back of the microbit lets you detect movement? I have a feeling all these are going to be pretty easy.
Yeah, so that one is the accelerometer, or the compass. Actually, both of those can do it, but the accelerometer's got to be the answer. Yeah,
that's why you're the CTO. All right, what is the part within the red boxes called? So these right here.
Those are input buttons.
Input buttons. All right, let's see. Show answer. Input buttons. All right, you're 3 for 3 so far. What is the part within the blue box? And I'm guessing that's right here, this little piece right here. Yeah, that's
that one. Yeah. That is a processor or CPU. We're going to go with CPU.
CPU? All right, let's see. CPU. All right, there you go. 4 for 4. Oops. Okay, that's okay. Next one here is, what is the name of the editor you have used to What is the name of the editor you have used to code your microbit? Oh gosh,
well, I mean, so this is a lovely one, because you could code your microbit. It's almost like I get a marketing slot. You can code your microbit in Scratch. You can code your microbit in Python. You can code your microbit in JavaScript. You, to my knowledge, can't code your microbit in Excel. So yeah, I think
all except Excel.
All except Excel, but I think they'll probably go with Python. I don't know. Let's see.
JavaScript editor. But this is probably a quiz that applied to a particular course that someone took.
Right. I think it applied to the original microbit release, those million, where there was a separate JavaScript editor by a company called Code Kingdoms in the UK.
There you go. So yeah, there you go. JavaScript editor. We'll still give you that one because we just saw you code in another one. So okay. So the next one is, what does the accelerometer do? Detect light, detect changes in speed, detect temperature, detect magnetism. Gosh, these are a little too easy, I feel.
It detects changes in, again, changes in speed will do, but if your speed doesn't change, then you probably won't detect it because it only detects acceleration. Well, no, changes in speed's fine. Sorry, you're right.
And as your speed approaches light,
goodness knows. I think
changes in speed.
That's
good.
Maybe the silicon crisis resolves as your speed approaches light, something like that.
So you're still 6 for 6. All right. Which of these is the brain of the microbit?
I'm going to go CPU.
Okay, CPU. I wish I could click these. I wonder why I can't. All right, so there you go. CPU is the answer. 7 for 7. Which of these allows short range communication? Ooh.
Well, so it is Bluetooth. I'm just trying to work out whether I could do some short range communication with the compass. There's a really neat example that was done at Lancaster where they use the compass or the magnetometer on the microbit. They use a hair tie to hold the microbit on a kettle lead and use the compass to detect whether the kettle is on or not, and to kind of monitor power. So it's not short range communication, but that is a pretty neat use of a compass because the electric field in the kettle wire generates a magnetic field that you can detect with the compass. So
we're going to need to bring you back here, and I'm going to need some redemption for these questions because I'm going to put together some much more difficult ones. But here you go. You're right. Bluetooth. So what code did you create for the first task? We're going to have to skip this one because we didn't take the course.
I think this gives me a chance to get one wrong.
Okay, let's see.
I think I did a motion sensor for the first task.
Considering the other question? Oh, temperature sensor. Oh, no. Yeah, they asked so much stuff that involved the accelerometer. You'd think it was a motion sensor, but yeah. All right. So now the last one, what code did you create for the second task? Okay, here you go. Another chance to get another one wrong.
I think it wasn't the temperature sensor. Let's say maybe it was a motion sensor. I'm going big on motion
sensor. No. You went all in there. Yeah. All right, cool. So you were 8 of 10. That's still good. Very well done. All right, I'm going to stop sharing here and we're going to bring it back to just us. And I'm going to find my list of notes here again. All right. So with all of the stuff that's going on with the microbit, I was hoping we could cover kind of what's new. So there's been a lot of stuff happening, and I want to say let's keep it to the last 12 months. But what's new with the whole microbit 2? You've talked about the differences between the microbit 1 and the microbit 2 a bit, but let's kind of dive in a little deeper. What are these differences? What's new with microbit in the last 12 months?
Yeah, so I think microbit v2 is our 12 months. Where are we in the year? So we can't quite. We launched. I'm going to go a tiny bit further back than 12 months. We launched a product called Microbit Classroom just as the pandemic started, and that was designed for in-classroom learning, but we pivoted it to be good for remote learning as well as the pandemic started. But that allows students and teachers to do kind of browser-to-browser communication so that the teachers can see students' work and collect their work and kind of restore lessons. So if you want to do a project that runs over 4 lessons or something, you can give the kids all back the same work, a bit like collecting books and hang them in. So that's kind of neat. And that's non-hardware. So everything I've talked about so far is kind of hardware, but we also do software and to make sure, the microbit is well supported in the classroom. So Classroom's super neat. Along with that came a whole bunch of new educational resources on the website and lots of kind of lesson plans, that kind of stuff. And we are always adding resources, lesson plans, other ways to program the microbit, that kind of stuff. I think in terms of the novelty of microbit v2, it's really all about the kind of bringing this, when we launched microbit v2, if I hold up a v1 and a v2 next to each other, the goal with this was really that you wouldn't really need to know which one you had. Everything that you could do on a microbit v1, this is my v1, everything you could do on a microbit v1 would work nicely on a microbit v2. And I think, the first 6 months of microbit v2 was all about making sure that people understood that compatibility. They knew clearly that they could use v2s for everything they already did. Because I think, this was interesting in understanding our audience. We spent a while trying to work out what microbit v2 should be, and it was really clear that compatibility was key. But what we've got to do now is start bringing out some of those kind of exciting things that we can do with the new v2 hardware, like ML, like responding to sound, making sounds. I think, I showed you that pull request, which is going on in the background. I don't think that will see, necessarily will be available to users that soon, just because from the time you build something that works on the device, there's a really long pipeline of testing in classrooms, understanding what the block language should be, understanding what the Python API should be. One of the things that we pride ourselves on at Microbit is making sure we do all of that kind of detailed educational thinking as well as just the cool tech. So, get the tech to work, and then we kind of go and test it in classrooms, talk to teachers about it, make sure that it's really appropriate for use, and also private. So if I plug this Microbit in, if it's still listening for sound, here's a little neat thing is we've got this microphone LED, so we can start to have conversations with kids about privacy and what it means to have devices that are capable of listening, recording sound. So that's a little that microphone indicator is actually a hole in the Microbit PCB and a side-mounted LED on the back of the board to give this nice, pretty microphone, because we wanted to find a way to communicate to kids with, without any English language, because the Microbit's used all around the world, that the microphone was on and listening. So that's another neat thing.
The importance of privacy is really big deal. I mean, even like mobile phones nowadays have started adding a little green light when the microphone's on or when your camera is recording. I mean, you still got to think though, right? I mean, if you really were compromised, a seasoned hacker or mischievous person could find a way to enable the microphone while disabling the LED.
Well, so that's interesting. Our LED is actually run off the same line as the microphone power. So if the microphone has power, the LED is on. So it's that was one of the kind of design decisions we made. And just to be really clear, that means that you can't do really power efficient recording with the Microbit microphone. And that's an okay compromise for us, because it's much more important that indicator is really clear. And you could give someone you could take the LED off, right? There's, once people got physical access, all bets are off. But, we spent a long time on this. I grabbed this beforehand. This is just got a torch behind it, but this is one of our kind of prototype microphone indicator boards. So this has got a whole bunch of different LED icons at different sizes, different layouts that we were using to test what would be the most effective way to kind of create that microphone.
That's so cool. That is awesome. Nice. So I mean, I know I interrupted you. Did you have more to talk about? I feel like maybe you were only halfway through what's happened in the.
So the other thing we've been working on with both NXP and ARM. So there's an ARM project called DAPlink that Microbit uses for that interface chip, the USB mass storage device, and we've been looking at how we can bring a kind of some more capabilities to that DAPlink interface, including making it really easy for students and teachers to log data and get that data off the Microbit easily. So kind of make it really useful in science lessons and have some kind of persistent storage on the device. So that's another thing it's not new because it hasn't happened yet, but it's happening.
Okay. So let's talk about some of the stuff that you all have done to keep things creative for the wider audience. So are there any I guess we can kind of touch on anything. And of course, the last year we've been the whole isolation thing, but have you done any events, or is this where the parrot comes in?
Well, I mean, so the parrot is more about the creativity of Microbit. I mean, really, I'm just seeing we've got 10 minutes left and I haven't turned the parrot on yet. So I'm just trying to shoehorn the parrot in. I hate the parrot. I love the parrot. So the parrot is the example of, the kind of things that we.
The parrot is the example of, the kind of things that we.
Oh, he's repeating what you're saying.
He's repeating what it. So this was one of the things. This is one of the things we really wanted. So this was one of the things. We really wanted. Shut up, parrot.
Shut up, parrot.
Oh, that's great.
Keeping stuff like this around in our minds when we're working on Microbit is really important, because that's what kids want to build, right? They don't want to build a light. I mean, they will build a light logger, and that's great, and it lets them do good science experiments in a classroom. But actually, if you can show them that they can build a parrot with a Microbit and it's infuriating and hilarious, that's what helps them kind of engage. And so one of my goals is bringing the parrot with Microbit V2. And I mean, I think so do you mean kind of creative in lockdown, or
I guess, yeah, just things that you've done, like things that Microbit has done to keep things moving, right? I mean, you can, I could tell you, like, for example, just for me, right, this whole isolation thing kind of gave birth to this particular live stream, right? We weren't able to go to events and interact with our developers. And so sure enough, my old co-host Alessandro came up with this idea, let's do a live stream, right? We need our developers. We need to talk to them and engage with them. And so this was born out of the last year of isolation. So I'm kind of wondering if there's anything that Microbit has done to kind of keep things creative and engaging with the communities.
So I mean, I think a lot of we found we did a really great session, which was, so we used to have Microbit Live. I mean, we probably will have it again, but Microbit Live is a Microbit conference. We had it for the first time in Manchester at the BBC or in Salford in I want to get the year right, 19, I think. And we did our first virtual Microbit Live this year, and that was absolutely fantastic. We had a kind of organizing committee from the Microbit partnership that pulled together this event, and because it was online, anyone could join. And there was some absolutely incredibly creative things that went on there. There's an artist called Captain Credible who had made an internet-connected Microbit room of musical contraptions. So anyone could log on to a page and put in a kind of sequence that would then get played in this room live on some contraptions that were all built with kind of microbits and other embedded devices that would like hit bells or play sequences or beat drums. And that was like, so this kind of huge interactive bizarre performance event that was really great. So I think realizing and kind of engaging with that huge around the world audience. And the other thing that I think has been really nice that's come out of this is a group inside the foundation. I can't take any credit for it, but have put together a kind of pilot for a Microbit Champions program. So we've got these Microbit champions all around the world now, kind of engaging with their communities and engaging with each other online, and that's been a really nice kind of thing to have as we all go remote as well. Yeah,
probably very, very similar to the ARM Innovator program that we have going on. Yeah, very cool. Thanks for sharing that. So I have just a couple questions here left, and it seems the theme, and we talked about this question already, and I'm very interested to hear from you about this. But we talked already about throughout this show, it's been pretty much tailored towards the younger audience, educational purposes. So the question here is, seeing as Microbit is tailored for a younger population in education, are there use cases for more seasoned developers? Do you ever get like those people who come in and say, Microbit's too low touch, or do you get some of these more seasoned developers in there?
Yeah, so I mean, I think that really changes with Microbit V2. So Microbit V1, I think was always you always hit memory limitations. 16K of RAM is really limited. And I think Microbit V2 with 128K of RAM, we're really going to see the lid coming off in terms of what we can do on the device. And I think it's, you can program the Microbit in C++, you can program it with Arduino, you can program it with Lancaster University's Codal, you can put Zephyr on it. So it is an affordable, kind of very well integrated embedded device. And the other thing that we've done with Microbit V2 that V1 didn't have was we've got super rock bottom power consumption. So on V1, power consumption wasn't a priority. V2, you can kind of run for 6 months on batteries if you put the device to sleep. And that makes a huge difference, I think, to kind of being able to do some IoT projects. So I would say actually, now is a great time for people to come and engage with the Microbit hardware, even in more professional or kind of hobby context, because the device is much more powerful and there are all these other ways to program it. I think, we also see it being picked up a lot in education much older than we at the Foundation target. I know Oxford University so we're based in Oxford, by the way, which is one of the reasons we have these lots of links to Oxford. Use the Microbit to teach their second-year computer architecture course. You build an operating system in assembler from scratch, and that course is actually all online. So if you're just interested in seeing that course, you can search. I think it's called. Well, the professor is Mike Spivey. So if you, I'll find a link. We can share it afterwards.
We'll find it. We'll put it in the description.
Yeah. So there's a course that's a really interesting kind of thing that people do with it, and I think some of this ML stuff is really neat. Ultimately, for £15, you can get an incredibly easy to program, debuggable board with a bunch of I/O, motion sensor, radio, Bluetooth. It's pretty powerful. I guess what else can I say on programming models? I think go and look at your favorite in kind of embedded environment, and in many cases they will have a Microbit port already there because it's such an accessible platform. We see quite a lot of people. Someone in the chat's pointed out that AdaCore has examples to program the Microbit in Ada, right? What? That's kind of awesome to see that as well. So I think, we focus. What's really important for us is that we build first for an education audience. But it's clear that doing that actually results in some really nice affordances, especially the volume, right? Means that the cost is low for professional developers or hobbyists as well.
Great.
Last thing on that, just to say, is there are more than 200 different accessories the microbit slots into. So we've got like LoRaWAN, Wi-Fi. There's loads of other stuff that you can plug the microbit into that also mean you can take it further.
That is great and good to know. Yeah, I mean, a lot of times it's the ecosystem that makes the board kind of more user-friendly or usable in general. So, you have like Raspberry Pis with their hats and the Arduinos with their shields. And so knowing that the microbit also has cards that you can plug into, I think adds to its usability.
And just a shout out, I think just to be clear, like a lot of that stuff is all community developed. And that's one of the most exciting things about working on the microbit is that we're a small team, right? And we have to stay focused. That's the only way we can do what we need to do for education and meet our kind of not-for-profit goals. But we've got this amazing community of people that volunteer their time to build, Arduino support or something for the microbit and keep that up to date and make it work for people. And I think that's part of, I kind of saw that starting in ARM, right? That's part of the ARM ecosystem as well. But I think it's been a fantastic and really exciting part of working on microbit.
And what would we be without community? And I'm looking at everyone out there watching the show. So yeah, awesome. Okay, well, John,
for more. If you're thinking this sounds interesting, come and get involved. That's the time to or now, anytime, not just now, not just then. Come and work with us. Come and pick an interesting problem that you can see and play with the microbit. See if you can solve it. Publish the code. Share it. That's fantastic.
Cool. So Jonny, in this last minute, we'll go just a couple minutes over here, but in this last couple minutes, let's just talk real quickly. If you could summarize, what does the future look like for microbit? Is there anything coming up that you can talk about?
I kind of already spent some of my coming up. We've got this data logging stuff, really interesting. We really want to understand what AI and ML look like in education. I think in the same way that microbit, when it came out, didn't just take an existing dev board and say, use this in education. We don't think it's appropriate just to take an existing ML thing. We need to take the existing ML things and shape it. We want to build on existing technology. We don't want to build from scratch, but we want to make that really right and appropriate for education context, private, secure, all that kind of stuff. So I think getting really stuck into that. Just really trying to take squeeze all we can out of this V2 hardware.
Very nice. Very nice. Okay. Well, Jonny, any last things you'd like to add before we close this episode out? This is your shameless plug.
Buy a microbit, take it to your local school, go and do a workshop with some people. Have some fun with the microbit devices. So many of the country projects, the things that have happened with microbit around the world have come from a single person going, I want to take that into my community. Or I want to go to the government and tell them to do it. I want to start a user group. And so there really is, Croatia did a whole country rollout because one person put up a kick or a crowdfunding campaign for it. So if you're sitting there thinking, I don't know how to have an impact, just start. That's what you need to do. Pick up the microbit, start, and start engaging people with technology because it's super rewarding.
Very nice. Very nice. Very well said. So Jonny Austin, thank you so much. I already had my closing sentence ready in my head, but I screwed up. Okay, so yeah, big thank you, Jonny Austin here, CTO of Microbit. Thank you so much for your time. We know it's valuable. We appreciate you spending it here with us. Everyone in the audience watching now or later, thank you so much for watching. If you liked the video, don't forget to hit that like button. All of the stuff we talked about today, all of the links and resources we mentioned, we'll make sure those are included in the description below. And don't forget, we go live here every week at 5 p.m. UTC here on the ARM Software Developer YouTube channel. Last reminder, ARM Dev Summit is still looking for proposals or for papers at devsummit.arm.com. Check that out. We'd love to get your submissions. This is going on until June 11th, extended from June 4th. So we'd love to have you all there. Once again, Jonny, I think you're muted. Parrot, what are we going to say? I think he said go to devsummit.arm.com.
I tried. Thanks very much. Thanks for having me.
Thank you all. Thank you, Jonny. Thank you, everyone. Have a good day. Have a good week.
Everyone. Bye.
Bye.